Good day, great minds, and welcome to Math Marathon class. If this is your first time of visiting our channel, please consider subscribing to help our community grow. Okay, today we want to look at a very important topic in mathematics, which is number bases. So number bases can be said to be the different systems we use to count or represent numbers. Now, for instance, we have base 10, we have base 2, we even have base 12, and different bases. Now, the number of digits, the base of that system tells you the number of unique digits available. For instance, in base 10, this is base, this is base. In base 10, you have numbers from 0 to 9, and when you count it, it's 10. When you count it, it's 10 digits. Then in base 2, we have 0 to 1. In base 12, we have 0 to 11, and then so on and so forth. Now, without wasting much of our time, let's just go straight into dealing with that is addition, subtraction, and then every form of arithmetics with the number bases. What is the grammar? But there's something I want you to note. You remember that 15, let me just say base 8 plus 40 base 8 is not the same thing as 15 base 10 plus 40 base 10. You get what I'm saying? 15, though there are 15, 40, 15, 40, but the base alone has changed the whole thing. This is 15 base 8, this is 40 base 8. They are not equal to 15 base 10 and 40 base 10. These are two different numbers, and they will give you two different answers. Yes. So now let's start with addition of number bases. Addition of number bases. Number bases. Okay. When we come to addition of number bases, I think we will start from the one everybody is familiar with, base 10. Of course, I know it is simple, but let's just start from there so that we have where to start before we move to other ones. Now we have 34 base 10 plus 89 base 10. So add 34 base 10 plus 89 base 10. 89 base 10. This is just normal addition we are familiar with. This is equal to, let me still write my solution. This is 34 plus 89. But remember, it is in base, it's in base 10. No need of writing it here. Now, 9 plus 4 is what? 13. Write 3. 8 plus 3 is 11. Plus 1, 12. 1. 9 plus 4 is 13. Add 3. 4. 4 plus 8, 12. So this is in base 10. Remember, it is in base 10. This one, very simple. Everybody knows about it. That one is done. So the other one, let's now move to. Okay, now let's look at this one. The solution is I, which is still reclaimed. I. Let's look at 47 plus 35. 47 base 8 plus 35 base 8. Right. Now this one is still normal addition, but there is a little difference. The little difference is there. Now this is it. 47 plus 35. But remember, it is in base 8. In base 8. This is just the base I wrote, so it's not part of the numbers. The numbers are 47 and 35. So let's just add them. Now 7 plus 5 is 12, right? 7 plus 5 is 12. Now, since this is in base 8, we don't write normal addition. 7 plus 5, 12. We write 2 and carry 1. But we don't do it here because this is in base 8, not in base 10. So what we do is 7 and 5 is 12. Now, that 12 divided by 8 divided by the base, that is 12 divided by 8. We first of all add this and then divide it by 8. Then when 8 divides 12, which is the value we got from 7 and 5, when 8 divides 12, we get what? 1 remainder what? Remainder 4. Then we write that remainder 4. And then you carry that 1. 8 in 12 is 1. Then we get 1 and we will be left with 4. Now, come to this one. 4 plus 3 is 7. Plus that 1 we got is 8. We still go and do 8 divided by 8. And 8 divided by 8, we get 1 remainder 0. We write that 0. Then the remainder, since the remainder has any other number to meet here, you bring it down, which is 104. Therefore, this, okay, we've already, this is equal to this plus this, don't need to write it, okay. 47 in base 8 plus 35 in base 8 is equal to 104 in base 8. This is base 8. Let me go again. In base 8, we have to consider the base we are dealing with. Here we are dealing in base 10. Now, of course, everybody knows how to add in base 10. But here we are dealing in base 8. And if you add anything and it is up to or greater than the base, you have to divide. And then from the normal addition, you write the remainder and then carry the other one to the next one. If had it been that when we added this and this, we got something like 7, we will just write the 7 here. There's no need of dividing with 8. But since it is more than the base, or it is equal to or more than the base, it is 12. The first one is 12. That was why we divided with 8. Then write the remainder, carry the 1. This one, 7 plus 1, 8. And that 8 is still up to the base. So we divide and got 1 remainder 0. So remainder 0 first, and then 1. So this one. Another one is we move to subtraction of number bases. Subtraction of number bases. Now, bases are in 7. This is 64. And this is 35. We are solving in base 7. And it is subtraction. Okay, now, 4 minus 5. Of course, it is not possible. This one is smaller than this one. We don't have anything like 4 minus. It's not that we don't have, like, it's not possible. So what do we do? Like normal addition and subtraction we do under base 10. We carry 1 here. Here. And of course, if it is in base 10, when you carry 1 from here and add it here, that one you carry is 10. So when you add it here, it's 14. This number becomes 14. But now we are in base 10 and in base 7. So when you carry 1 from here, that 1 you carried is 7. So when you add 7 to 4, gives you 11, right? 11. So this is 11 minus 5, and that is 6. You notice that we wrote the 6 directly because 6 is not up to the base. The base is 7. So we wrote the 6. Now remember, we've already collected 1 from 6. What is left is now 5. Then 5 minus 3 is 2. Therefore, this is equal to 64 base 7 minus 35 base 7 is equal to 26 base 7. It's clear. There's nothing much to explain here. It's clear. Subtract. The only thing that is not hard though. That instead of when you collect 1 here, you call it 10. It is in base 10. This is 14. But since it's in base 7, when you collect 1 here, that 1 you collected is 7, and 7 plus 4 is 11. 11 minus 5, 6. 5 minus 3, 2. This one will be easy now. That you should remove this one from this one. Both of them are in base 5, so it won't be hard. This is 5, 3, 4. And this is 3, 1, 6. All in base 5. All in base what? 5. You should always remember that this is just the base, not part of the number. So now we go in base 5 and we are subtracting. So 4 minus 6, of course, you know is not possible. So when you take 1 here now, from what I explained, when you take 1 from 3, that one becomes 5 because we are subtracting in base 5. So 1 out of here is 5. 5 plus 4, 9. Then 9 minus 6, we are left with 3. So you write 3, no need to divide. We are left with 2 here. 2 minus 1 is still 2. Is 1. 1. Then 5 minus 3 is 2. Therefore, this 5, 3, 4 base 5 minus 3, 1, 6 base 5. Base 5 equal to 2, 1, 3 base 5. Okay, that is it. Let us to get to multiplication. Multiplication of number bases. Of number bases. Okay, this is multiplication. Now the first one says 32 times 3 in base 4. As you can solve we are 36 times 3 in base 4 times 3 all in base 4. Now you should solve this one. Then base 4. This one. Okay, this is 3, 6 and multiply by 3. Remember, we are dealing in base 4, so don't forget. Base 4. Now, we start with 3 times 6 is 18, right? 3 times 6 is 18. Now, 4 in 18. Remember, the base is in 4, and what we got is far bigger than 4. So 4 in 18, what do we have? We have 4 remainder 2. So we have 2. We only have 4 remainder 2. Then 3 times 3, 9. 9 plus 4 is 13. Right? We have 4. 3 times 6 is 18. Then 4 in 18 is 4. 4. Remainder 2. We wrote 2 and we hold the 4. Then 3 times 3, 9. 9 plus that 4 we are holding is 13. Now, 4 in 13 will give you 3, 3 remainder 1. I'm correct, right? 4 in 13 give you 3, 3 remainder 1. And then since there is nothing else to multiply, bring that 3 down here. Therefore, this is equal to 312 in base 4. So when you multiply these two things in base 4, you get 312. This is this is 45. This is 45, and this is multiplied by this is 34. Base is base 6. Base 6. Now 4 times 5 is 20. 4 times 5 is 20. Now 6 in 20. We have 3, 3 remainder 2. 3, 3 remainder 2. Now 4 times 4 is 16. 16 plus 3 is 19. Now 6 in 19 is still 3, 3 remainder 3. 3, 3 remainder 3. Then since the last 3 there is nothing to meet, no number to meet, we put that 3. Let's go again. 4 times 5 is 20. What did I do here? So 4 times 5 is 20. 6 in 20 is 3, 3. This is the remainder 2. Okay, we wrote that 3. And 4 times 4 is 16. This is 19. This is remainder 1, not remainder 3. For sure. This is remainder 1. 4 times 4 is 16. 16 plus 3 is 19. So 6 and 19 is 3, 3 remainder 1, right? So now that side is gone. Then we come over to this side. Now 3 times 5 is 15. And then 6 in 15 is 2, 2 remainder 3. 2, 2 remainder 3. We write the 3. Cool. And then we keep the 2. Then 3 times 4. 3 times 5 is 15. 3 times 4 is 12. 12 plus 2 is 14. Then 6 in 14 is 2, 2 remainder 2. Remainder 2. Then we write the last 2. Let's check it again. 3 times 5 is 15. Then 6 in 15. We have 2, 2 remainder 3. 12 times 40, 50 remainder 3. That is it here. Have 2. Then 3 times 4, 12. 12 plus 2 is 14. 6 in 14 is 2, 2 remainder 2. 2. Okay. Now, when we add them, we have 2, 4, 5, 2. Therefore, pardon me, I have to use this place. Therefore, this times this in base 6. This times this in base, okay, let me write it. 45 times 34 in base 6 equals 2, 5, 4, 2 in base 6. In base 6. 6 is never part of the thing. It's in base 6.